Okay, so this is a follow-up to my recent video talking about automating deployments using GitHub workflow. In that video, I discussed deploying the project to production whenever someone pushes changes to the main branch of the project's repository. But in that video, the VPS server was already set up and all the software was installed, like PHP, NGINX, MySQL, and others. So in this video, we will spin up a server from scratch. So for this, we will be using DigitalOcean, but the topics I will discuss in this video are applicable whether you prefer a different hosting provider like Linode, AWS, Vultr, and others. So let's get started. On DigitalOcean website, first, of course, you must create an account. If this is your first time trying out DigitalOcean, they usually offer a $200 credit when you sign up. So you can use that to try out their service, so it's basically risk-free. Just a little heads up, you may need to enter your payment details upon signing up. But don't worry, they won't charge you anything until you have consumed all your free credits from signing up. Okay, so after creating an account and getting verified, yes, they will verify your payment details first, which is why they need to collect them upon signing up. So here's the DigitalOcean dashboard. Now let's create our server. There is a Create menu at the top. Select Droplet from it. The term Droplet, by the way, is just a fancy name DigitalOcean uses for virtual private servers. Here in the region section, it is recommended to choose the region closest to you or your customers. I'm going to choose Singapore. Next, you have the option to select the Linux distro you want to use. I'm going to choose Ubuntu. In the version drop-down menu, it's recommended to choose the latest version, though you can also select older versions if needed. In the Droplet section, you have a few different options based on the requirements of your project. General purpose, CPU optimized, memory optimized, and storage optimized for dedicated CPUs. I'm going to choose the basic option for now. You also have the option to select the type of CPU you want for your server. I'm going to choose Premium AMD with 2 CPU cores and 2 GB of RAM. Okay, in the authentication method section, you have two options here. Connect via SSH key or via password. For now, I'm going to choose password authentication for the root user, because we will disable the root user later. It's generally not recommended to always use the root user as it has global-wide permissions on your server. I will discuss that later, along with the risks of using the root user when interacting with your server. For now, I'm going to supply a password for the root user. In this section, let's give our server a name to easily identify it. So I'll call it prod server, which means production server. And you can also add some tags here to easily find or identify the server if you have multiple servers configured on this account. After all of this, hit the Create Droplet button to spin up our server. Okay, our server is created and it will be associated with an IP address, as you can see here. Now, let's log into our server and do some more configurations. In your terminal, you can log into your server via SSH. Type SSH space root and then the @ sign followed by the IP address of your server and hit enter. When logging in for the first time, you'll see a prompt, so just type yes to proceed. The IP address of your server will then be added to the list of known hosts, and you can supply your password then. When you start typing your password and don't see any characters appearing on the terminal, that's normal. This is just a security feature. Continue typing your password and hit enter when you're done. Okay, once you see this in your terminal, you are now logged in. I'm going to clear my screen. First things first, let's update the local packages of the OS. You'll see a list of local OS packages that can be upgraded to the latest versions. To upgrade these packages, run the command apt upgrade. When prompted if you want to continue, just type yes and wait for it to complete. When you see a prompt, let's just accept the default option, which is to keep the local version currently installed. Okay, the upgrade is complete. Clear the screen by using the keyboard shortcut Command K if you're on a Mac, or type the clear command if you're on Linux, and if you're on Windows, type CLS and hit enter. Now, let's add a new user that we will use permanently so we can disable the root user for logging in. Type the command add user, followed by the username you want to use. You will be prompted to specify a password for the new user. After this, you can also fill out additional optional information. But you can skip these by pressing enter or return to skip each one. When asked, is this information correct? You can type yes and just hit enter to accept the default answer, which is yes. Next, we need to add this new user to the sudo group. This will allow the user to execute commands with super user privileges, but still won't have complete control over the system compared to the root user. Okay, after this, the user is now a member of the sudo group. Let's switch to the newly created user by typing su, then dash, followed by the username. Okay, we are now logged in with this user. To go back to the root user, just type exit, and if you run the exit again, it will log you out from the server. Now, to log back in using the new user, you can SSH to your server just like before, but this time, instead of root, use the new user's username. Supply the password, and you will be logged in as the new user you created, not the root user. Right now, we are logging into our server using password-based authentication. But let's enhance the security of the server by using SSH key-based authentication instead. I'm going to log out first. On my local machine, this is where I'm going to create an SSH key pair. You can choose a directory that you like, but since I'm on a Mac, I will create this inside the .ssh directory of my machine. To create an SSH key pair, you can use the typical RSA algorithm, but I'm going to use the elliptic curve digital signature algorithm, which is as secure as an RSA algorithm, but has a shorter keys. I will also specify the number of bits as 521. After running the command, it will prompt you to enter a name for your key pair. I will just name it ID Cooper. After this, it will ask for an optional passphrase that adds additional security. I will leave this empty for now. After successfully generating an SSH key pair, you should see a random art like this displayed on your terminal. If you list the contents of the directory where you generated the SSH key pair, you should see these two files. The file with the .pub extension is the public key, and the other one is the private key. Next, we need to copy the value of the public key to the authorized keys list on our server. To do this, run the SSH copy ID command, specifying the username of the account, followed by the @ symbol, and the IP address of your server. It's similar to running an SSH command to log in. When you hit enter, you should see a prompt to enter your password for authentication. If successful, you will see a message indicating that your public key has been added to the authorized keys on the server. To log in, you can copy this command and run it. As you can see, you're now logged into your server without entering a password. We are now using an SSH key-based authentication to log into our server, which is far more secure than password-based authentication. The next step is to disable the ability to log in as the root user. To do this, we need to edit the SSH configuration file. Type sudo vim, then this is the directory where the SSH config file is located. Supply your password when prompted. Okay, in this file, we need to disable the permit root login value by changing it to no. We should also enable the pub key authentication, which controls whether the public key authentication is allowed. Uncomment the line that says authorized keys file, which specifies the file or files that contains the public keys used for authentication. Additionally, enable the password authentication option and set it to no to disable the password-based authentication. This will require SSH key-based authentication from now on. Also, enable the option to prevent empty passwords. Save the changes. If you're using Vim, hit escape to exit the editing mode, then type :WQ to save the changes. Okay, next, restart the SSH server for the changes to take effect. Okay, now let's test this. If you try to log in as the root user, you'll see that even with the correct password, access is denied because root login is now disabled. If you log in using other user via SSH, you should be able to access the server successfully. Now, the reason why it's not generally recommended to always use the root user is that, as I mentioned earlier, this user has global-wide permissions on your system. This means that it can execute commands, potentially modify sensitive files, and change system settings, either intentionally or accidentally. I just want to share a recent experience of mine. A client asked for help because their website was running extremely slow, taking almost a minute to load a simple web page. When I logged into their server, I noticed that the CPU was constantly at 100% utilization every single minute, 24/7. This was extremely unusual, even for a site with high traffic. And then I discovered a process called kdev-temp-fsi that was consuming all the resources. So I tried to terminate the process, but it kept responding every single time. Upon further inspection, I found a cron job entry related to this process. After some research, I found out that the kdev-temp-fsi is a crypto mining malware that had been injected into my client server. I don't know the full story about how this happened, but I suspect it was due to the server being insecure. The client was using the root user to interact with the server with a password-based login, and the password was very weak. So it seems that their server was infiltrated and used for cryptocurrency mining. To check, I pinged the IP address in the cron job entry, and we received a response indicating that the server was still active and possibly exploiting other servers that were not properly secured. Okay, let's terminate this process. A quick Google search of kdev-temp-fsi reveals many articles and reports confirming it is a crypto malware. This incident occurred in 2022, so 2 years ago at the time of this recording. So this serves as a warning to properly secure your servers. Okay, let's continue. First, let's log out from the server because I want to show you a quick shortcut for logging in. In the directory where your keys are located, you can create a config file here. In this config file, you can specify the host key and assign an alias. For example, Cooper user. Then specify the user key for the username of the account. Next, use the hostname key and enter the IP address of your server. For the identity file key, enter the path where the private key used to log into your server is stored. Remember, this should be a private key, not the public key with the .pub extension. After saving the file, you can log in using the alias we created instead of specifying the long string with the username and IP address. Simply use the alias like this. And as you can see, you are still able to log in. Okay, now it's time to install everything we need to run our website. In our case, we need to install PHP, NGINX, MySQL, NodeJS, and certbot, so we can issue an SSL certificates from Let's Encrypt. Press enter to continue when you see this prompt. Okay, after that, we can install PHP by running this command. I will link all the commands I use in the video description if you want to try it out yourself. Say yes when prompted if you want to continue. After the installation is complete, we will also install common PHP extensions that are used in the vast majority of PHP projects. Again, I will link all these commands in the description below. If you don't want to be asked every time if you want to install something, you can append -y at the end to automatically approve all prompts. Okay, after the installation is complete, let's check if PHP is installed by running this command. If PHP was successfully installed, you should see the version of PHP that was installed, which is PHP 8.3.11 at the time of this recording. Next, let's install Composer, which is PHP's package manager. After that, run this command to check the version of Composer installed. Okay, it should show you that you have the latest version. Now, let's install MySQL for our database. Supply your password. Say yes and wait for it to finish. After this, we'll run some security steps to ensure our MySQL installation is secure. The first step is to set up the validate password component. Say yes and choose the strong option for password strength. Okay, after this, let's remove the anonymous users. Say yes. And also disallow remote root login. Next, remove the test database and reload privilege tables. By saying yes to all these options, we are following best practices for a production database. Now, let's log into MySQL. Currently, you should be able to log in without supplying a password, but we'll fix that shortly. First, let's create a database for our application. Run create database, then choose a name for your database, and don't forget the semicolon at the end. If you list all the databases, you should see the one that you just created. Next, let's create a new MySQL user. I'll paste the command here so you don't have to watch me type it all out. Again, I will include all the commands in the video description below. As you can see, we got an error saying that the password we specified doesn't meet the policy requirements because, as you remember from the previous step, we chose the strong password requirement. So let's modify the password a little bit. Let's make this a capital C and add 2 asterisks at the end to make it a bit more complex. Okay, it succeeded. After this, we will run the command to grant all privileges to the MyApp database for the current user, and then flush the privileges. To exit MySQL, simply type exit and hit enter or return. Next, we need to install our web server. We will be using NGINX for this example. So run the command to install NGINX, supply your password, and say yes to confirm. Okay, NGINX is installed, so let's check the version to ensure it's up to date. Okay, it is. So to test if NGINX is working, copy the IP address of your server and paste it in your browser. If you see the NGINX test page, then NGINX is installed, enabled, and working correctly. Next, let's install NodeJS. To simplify this process, we'll use a version manager for NodeJS, such as NVM. NVM is a popular tool for managing and updating NodeJS versions easily. First, go to its official GitHub repository and copy one of the installation commands from the installation section. After the download is complete, run the command from the terminal. Now that NVM is installed, you can verify it by checking its version. Okay, so next, let's install Node.js itself. So to get the latest stable version, run the command to install the long-term support version, which is the LTS version. This is usually the most stable release. So once it's done, check the Node.js version to confirm. At the time of this recording, Node.js is at version 20.17. Also check the NPM version. So the latest version should be 10.8.2. Okay. Now I will start cloning one of my project files. And of course, you can use your own for this. In the clone drop-down box, choose to clone via SSH. Back in the terminal, place the project files inside the default directory for NGINX sites. If you list the contents of this directory, you will see the test HTML file we saw earlier in the browser. Okay, so when attempting to clone the project, you might encounter a permission denied error like this. Git was already included in this version of Ubuntu, by the way, but we need to take ownership of this directory first. Okay, so after changing the ownership, try cloning again. If you still receive a permission denied error, it's likely because GitHub access hasn't been granted to the server for SSH-based cloning. Although password-based authentication is an option, SSH key-based authentication is recommended for security. So let's generate an SSH key pair that we can add to GitHub to clone the repo without entering our password. First, navigate to the .sh directory, where the authorized keys is located. Generate a new SSH key pair as before, naming it ID GitHub, like this. Once the key pair is created, output the content of the public key, which is what you need to add to your GitHub account. So use the command cat, then specify the ID GitHub.pub, and manually copy the output. In your GitHub account, go to the Settings menu and select SSH and GPG keys. Click on the new SSH key, give it a title like, for example, Demo SSH, and paste the public key from your server. If you have two-factor authentication enabled, you'll need to authenticate. Okay, after adding the key, you should see it listed in your SSH keys list. You can check out GitHub's guide on adding SSH keys through this link. Let's visit this link now, where you'll find the step-by-step guide. Okay, so the following step is to add the SSH key to the SSH-AGENT. Copy the command from GitHub's guide, go back to the terminal, and run it. Okay, this message indicates that the SSH-AGENT is running. Now add the SSH private key to the SSH-AGENT with the following command, specifying the full path to the private key. If successful, you should see this message saying the identity has been added. Okay, next, test the connection with the provided command. If you receive a successful response, GitHub can now securely connect to your server, and you are ready to clone your project's repository. Okay, now let's go back to the HTML directory and try cloning the repo again. Under the SSH tab, copy the clone command and use it. As you can see, we have successfully cloned the repo using SSH Authentication. This method is much more secure and convenient since you don't have to enter your password each time. If you list the content of this directory, you'll see our project directory there, which contains our project files. Let's go inside it and examine the files and folders. Okay, so next, let's install the Composer dependencies by running composer install. Okay, we encountered a couple of errors here because the PHP SQLite and Imagic extensions are not yet installed. Okay, to fix this, first install the SQLite extension by running the appropriate command. Supply your password and wait for it to complete. Once that's done, proceed to install the Imagic extension. After the installation is complete, run composer install again, and it should begin downloading the project's dependencies. Since this is a Laravel project, the next step is to generate an app key. Run PHP artisan key generate. But as you can see, it fails because the .env file is not yet present in the root of our directory. Or in the root of our project, I mean. Let's make a copy of the included .env.example file to create the .env file. Okay, I misspelled the copy command, so let me correct that. Okay, now that we have the environment file, try running PHP artisan key generate again. Okay, it still fails because the file is new and the owner of the file is actually the root user. Okay, so to fix this, we need to take ownership of the environment file. Run the command sudo chown, then specify your username and then the .environment file. Okay. Now that we have ownership of the file, run the PHP artisan key generate again, and it should succeed. Okay, we have successfully set up the app key, so let's move on to the next step. Let's quickly set the proper database credentials in our .env file. The database name is myapp. The username is Cooper, and set the password. Save the file after making these changes. Next, let's install NPM Dependencies. And one quick note, installing or building NPM dependencies on your production server might require significant amounts of memory and CPU usage. This can slow down your server, and if your hardware is limited, for example, with only one CPU core and 1 GB of memory or less, you might want to consider automating the deployment process using GitHub workflows to offload these resource-heavy tasks to GitHub. I discussed this in one of my videos, which I will link in the video description below if you want to check it out. So for now, let's install and build our NPM dependencies here for the sake of this demo. Okay, with all the NPM dependencies installed, let's proceed with setting the proper permissions for our project directory. This is to ensure that the user or the web server can access and modify the necessary resources without issues. First, let's run this command. So it changes the ownership of all files and directories in the current directory so that the current user becomes the owner and the group ownership is set to www data. This www data group is typically associated with a web server, like Apache or NGINX on many systems. Setting the www data as the group owner ensures that the web server processes running as www data have the appropriate permissions to read and write files within the web application directory. So for example, if someone uploads a file, the web server process will have permission to handle it. Next, this command finds all files, signified by this -type F in the current directory and its subdirectories, and set their permission to 644. This configuration allows the owner to read and write the file, while the group and others can only read it. I'll link all the commands in the video description for your reference. Then, this command finds all directories, signified by the -type D in the current directory and its subdirectories, and set their permissions to 775. This permits the owner and the group to read, write, and execute or enter the directories, while others can only read and execute them. Following this command changes the group ownership of the storage and bootstrap cache directories, as well as their contents, to the www data group. This ensures that the web server, which runs as the www data user, has the correct group permissions to read from and write to these directories. Finally, this command grants read, write, and execute permissions to both the user, which is you, and the group for the storage and the bootstrap cache directories, as well as their contents. This is done to ensure that the web server or application has the necessary permissions to read from and write to these directories. Okay, so after setting up the necessary permissions for our project files and directories, let's configure an NGINX site so we can actually view our project online. This process involves managing NGINX virtual hosts, or server blocks as they call it, which allows hosting multiple sites on a single server. Let's start by navigating to the directory where server blocks are usually located. If we list the files inside, you'll see a file named default, which is the pre-configured server block showing the example NGINX page we saw in the browser earlier. So let's create a new file here named after our domain. You should name this file according to your project or website. So inside this file, I'll paste an NGINX site configuration copied from the Laravel documentation. I will include all the commands and necessary files in the video description as I said. Okay, next, we need to modify some parts of this configuration file. First, specify the domain name in the server name directive. For now, I will set this to my domain name since I'm using my own domain for this demo. Okay, since this is a Laravel project, I will change the root directive to point to the public directory of our project. After making these changes, save the file. The next step is to create a symbolic link of the server block we just created in the site's enabled directory to enable the server block. Ensure you specify the full paths for the sites available and sites enabled directories as shown. Okay, after creating the symbolic link, navigate to the sites enabled directory to confirm that the link was created successfully. Okay, next, to fully enable the server block, let's restart the NGINX server. So first, let's go back to the project directory and test the configuration first for errors or misconfiguration with this command, sudo nginx-t. If the test is successful, you'll see a confirmation message like this. Then restart nginx with sudo systemctl restart nginx. Before we can check the site online, let's add our domain name to DigitalOcean. So let's go to DigitalOcean. Under the Create menu, select Domains or DNS and enter your domain name. Click Add Domain. Once the domain has been added, you will be directed to a page to set the host name. So here, configure the DNS records for DigitalOcean to ensure your domain resolves correctly to your server. So in my case, I registered my domain name with Namecheap. So I will log in there and show you how to update your DNS settings. In the domain name's NameServer settings, you need to add a custom DNS entries to correctly resolve your domain to your DigitalOcean server or any other hosting provider you choose. Okay, so back to DigitalOcean. In the host name, in the text box, type the @ symbol. This is a shortcut in DigitalOcean to add the domain name as shown at the bottom of the text box. And then specify where this domain will redirect, which should be the server you just set up. If you have multiple servers, select the correct one and then click the Create button. Once the domain has been added, let's check it in the browser. Okay, the domain should resolve to our server, but we encountered a 502 bad gateway error. I suspect this is because the PHP-FPM extension hasn't been installed yet. Let's verify this quickly. Return to the terminal and run this command, php 8.3-m. This command lists all the modules or extensions installed on your system. And yes, it appears that PHP-FPM is not installed, which is causing the error. So let's install it with sudo apt install php 8.3-fpm. After the installation, restart the PHP-FPM with sudo systemctl restart php 8.3-fpm. Okay. Let's go back to the browser and refresh the page. Okay, we still have some error, but now it's Laravel's error page. It's likely because the database for this project is still empty. Okay. Return to the terminal and run the migrations with PHP artisan migrate. Okay, after running the migrations, test the site again in the browser. Okay, so now the issue is related to Vite. Since this project is a single page application or SPA, you need to build your assets for production to resolve this issue. As I mentioned before, I recommend deploying your production code using GitHub workflows to automate this process and utilize GitHub servers to build your production assets. This approach can help avoid problems if your server has limited resources. Again, I will link my video on automating the deployment process in the video description. So for now, let's continue building the assets here. Run npm run build. If you encounter a permission denied error, you might need to make the TypeScript compiler executable. But if you're not using TypeScript, you can skip this step. Okay, once the build is complete, let's issue an SSL certificate to enhance your website security. Nowadays, having an SSL certificate is highly recommended. We'll use certbot to issue a Let's Encrypt SSL certificate. So first, let's install certbot. Okay, after the installation, issue an SSL certificate for your website. Follow the prompts to enter your email address and agree to the terms. Once the SSL certificate is issued and configured, refresh your website in the browser. You should now see the SSL certificate applied, and your site should be secured with HTTPS. Lastly, before we conclude this video, there might be an issue you encountered after some time when trying to pull the latest changes from your Git repo. You might see a permission denied error like this, which can be confusing since you have already added the SSH key to GitHub. This error might occur because the SSH agent on your server might stop or expire at some point. So to prevent this, we'll add the configuration file in the .ssh directory to maintain a persistent connection and avoid interruptions. Create a config file and add the necessary configuration values. I will include these in the list of commands and files in the description below. Okay, save the file, then change the ownership to your user with sudo chown, specifying your username and the config file. Then verify that you own the file. Okay. Now try pulling the changes from your project root again. You should be able to connect to GitHub without restarting the SSH agent and adding your SSH keys again like this. Okay, that's it for today, everyone. I hope you found this video helpful. If you did, please hit the like button to help boost the algorithm so it can reach others who might benefit from it. And if you haven't subscribed yet, consider hitting that subscribe button. Thank you for watching, guys. I'll see you next time.